Hello everyone, today I'm going to be presenting a video summary on prediction using Markov chains. What's Markov chain? A Markov chain or a Markov process is a stochastic model describing a sequence of possible events in which the probability of each event depends only on the state attended in the previous event. Let's look at it further. A Markov chain is a stochastic process, but it differs from a general stochastic process in that a Markov chain must be memoryless. That is, the probability of the future actions are not dependent upon the steps that led to the present state. So, what do you understand by this? If you're given a certain situation, if you predict the future, we don't. Let's take an example. Suppose we have points A, B, and C, and I want to go from A to C. Right now I'm at state B and I need to go to state C. The probability of choosing the means of transport from B to C does not depend on how you take travel from A to B. It may be from flight, from a car or anything. It just depends on what are the available means of transport at B, right? That's what the Markov chain briefly describes. There is a mathematical expression relating to it. For any positive integer n and possible state I0 to In of the random variable, knowledge of the previous state is all that is necessary to determine the probability distribution of the current state. So P of xn equal to Inx, given xn minus 1 equal to In minus 1, we have equals P of xn equal to In, given x0 equal to I0, x1 equal to In, and so on. That's the conditional probability. So here's an example. So let's suppose it's a weather prediction example that the weather may be rainy, cloudy, or sunny. So if the current state is rainy, it has 0.6% or 60% probability that the next day might be rainy, and 0.1% probability or 0.1 or 10% probability that the next day is sunny, and so on. That's what is given below. And we use a transition matrix for Markov chain. The transition matrix Ft for Markov chain at time t is a matrix containing information on the probability of transitioning between states. In particular, given an ordering of matrix rows and columns by the state space S, the I, jth element of the matrix Ft is given by P of t of ij equal to P of xt plus 1 equal to j is given P of t equal to I. This means that each row of the matrix is a probability vector and the sum of its entries equals 1. Transition matrix. A real world problem uses transition matrix to tally the transition probabilities. Every state, the state space is included once as a row and again as a column. And each cell in the matrix tells you the probability of transitioning from its row state to its column state. So in the matrix, the cells do the same job as the rows do in the diagram. These are some photographic views of state transition diagram and the transition state. Now look at it, the sum of each rows and each column sum up to 1. That's how it works. Application of Markov chain. Predicting traffic flows, communication networks, genetics and queues are examples of Markov chain can be used to model performance. The page rank of web pages as used by Google is defined by Markov chain. Markov chain can be used for forecasting, which can be any kind of forecasting like weather, temperature, sales, etc. Markov chain have many health applications like modeling spread and progress in infection and diseases. This is all about Markov chain. Thank you, Anana.